Hi guys, welcome to the another lecture of Gen AI course. So today we'll be seeing GANs in detail. So in today's lecture we will be seeing introduction to neural networks, overview of GANs, and uh, type of GAN that is cyclic GAN. So yesterday we have seen, a bit of introduction to a neural network. So the original perceptron was designed to take a number of binary inputs and produce one binary output, or that is 0 or 1. Okay. The idea was to use different weights to represent the importance of each input, and that the sum of the values should be greater than a threshold value before making a decision like yes or no, or a true or false, or 0 and 1. So let's example, imagine a perceptron. The perceptron tries to decide if you should go to the concert. Is the artist good? Is the weather good? What weight should this facts have? So a perceptron is an artificial neuron. It is inspired by a function of a biological neuron, which plays a crucial role in artificial intelligence. It is an important building block in neural networks. To understand the theory behind it, we can break down its components. The perceptron inputs, uh, we have a weight that's multiplied. Okay. Then we have a summation function and a threshold, a value is given, and the activation function. So the summation should be greater than threshold. Okay. A perceptron receives one or more input. A perceptron includes, it's called a nodes. These nodes are both a value and a weight, and input node have a binary value of 1 or 0. This can be interpreted as true or false, yes or no. And we have node weights are values assigned to each input. Weight shows the strength of each node. The higher the value means that the input has a stronger influence on the output. And the summation function, the perceptron calculates the weighted sum of its input. So x1 into w1 plus x2 into w2 plus xn into wn. Bracket. The threshold is the value needed for the perceptron to fire output. Okay. Otherwise, it remains inactive. The threshold is to check whether the given network is active or not. And last come activation function. After the summation, the perceptron applies the activation function. The purpose is to introduce non-linearity into the output. It determines whether the perceptron should fire or not based on the agreed output. Okay. And the final output of the perceptron is the result of the activation function. It represents the perceptron decisions or prediction based on the input and the weights. The activation function maps the weighted sum into binary value. The binary 1 or 0 can be interpreted as true or false or yes or no. Okay. So perceptrons can learn from exercising through a process called training. During training, the perceptron adjusts its weights based on observed errors. This is typically done using a learning algorithm such as the perceptron learning rule or a backpropagation algorithm. The learning process presents the perceptron with labeled examples where the desired output is known. The perceptron compares its output with the desired output and adjusts its weights accordingly, aiming to minimize the error between the predicted and the desired outputs. The learning process allows the perceptron to learn the weights that enable it to make accurate predictions for new or unknown inputs. So it's important to know that while perceptrons were influential in the development or in artificial networks, they are limited to learning linearly separable patterns. However, by stacking multiple perceptrons together in layers and incorporating nonlinear activation function, neural network can overcome this limitation and learn more complex patterns. The defines the first step into neural networks. Perceptrons are often used as a building blocks of more complex neural networks, such as multi-layer perceptrons or deep learning neural networks, as we can see here. By combining multiple perceptrons in layers and connecting them in a neural structure, these models can learn and represent complex patterns and relationships in a data, enabling tasks such as image recognition, natural language processing, and decision making. Okay, so like next we will be seeing the GANs, like as we already discussed yesterday. So we saw what GAN is. So, like there will be two networks, a generator and a discriminator, for which where a generator will be creating a fake images and given to a discriminator, where discriminator should be checked the images that was generated by generator whether it is a fake or real. So this process goes on until the generator creates a perfect fake image, and the discriminator is trained until it's perfectly accurately able to detect whether the given image is fake or not. Okay, so this is the example where an image is given and the generator tries to generate exact image with a different fake image, and this is the same, like this is the input and this is the output, and this will be the ground truth value, like after the after process thing. Okay, and also you can see like the input is given an hours, and it will generate in a zebra form. Okay, so we have a different types of GANs here. We have a generic GANs, text to image GANs, image to image GANs. So DC GAN and C GAN is a very important GAN, whereas in text GAN, GAWW and stack GANs and stack GAN plus plus and SR GAN, Disco GAN, Cycle GAN, Texture GAN, Ketchy GAN, and Art GAN and Semantic GAN comes under image to image GAN. So there are so many every week new GANs papers are coming out. So it's very hard to track them all. There are many different types of GANs that are coming up. So you can follow this GitHub for all like for one activity for compiling all the named GANs. Okay. So now we will be seeing cyclic GAN. So cyclic GAN is used to transfer characteristic of one image to another, or can map the distribution of images to another. In cyclic GAN, we treat the problem of an image reconstruction problem. We first take a image input X and using the generator G to convert into the reconstructed image. Okay, then we reverse this process from reconstructed image to original image using a generator. Then we calculate the mean square error loss between real and reconstructed image. The most important feature of this cycle GAN is that it can do this image translation or an unpaired image where there is no relation exists between input image and output image. Okay. So come to actually like all the adversarial network cycle cycle can also have two pairs of generator and discriminator. The job of generator is to produce a sample from the desired distribution, and the job of discriminator is to figure out the sample is from actual distribution or from the one that are generated by generator. Okay, the cycle GAN architecture is different from other GANs in a way that it contains two mapping functions that act as generator and the corresponding discriminator. Okay, so first we'll be training a generator with a data. So this will be the day. Let's suppose this is the data that we have already trained generator, and we have also trained discriminator with fake images, uh, like fake images, whether telling it's real or not. Now we have given a new input to a generator, and it generates the new image by mapping different distributions to the image. Here you can see the image is completely changed. Here, on it is changed to a photo, and then a zebra to a horse, and summer to winter, like that. So the generator generates it. Now the discriminator task is to uh, find out whether the given image is fake or real. Okay. So each cycle and generator has three sections: encoder, transformer, and decoder. The input image is passed into the encoder. The encoder extracts features from image by using convolutions and compressed the representation of image, but increased the number of channels. The encoder consists of three convolutions that reduces the representation by 1/4 of actual image size. Consider an image of size 256, 256 and 3, which we input into the encoder. The output of the encoder will be 64, 64, and 256. Okay. Then the output of the encoder after the activation function is applied is passed into a transformer. The transformer contains six or seven residual blocks based on the size of the input. The output of a transformer is then passed into a decoder, which uses 2D convolutional block of fraction styles to increase the size of representation to original size. Okay. So this is the cyclic GAN. So that's it about today's lecture. Thank you for joining. If you are new to this channel, please do subscribe. And if you have any doubt, please do comment out and like this video. That's it. Thank you.